I'm Prem Paul. I have the pleasure of being Vice Chancellor for Research and Economic Development at your university. It is indeed my pleasure to welcome you and thank you for joining us today for our Spring Nebraska Lecture. It's the first one of the 2013 Chancellor's Distinguished Lecture Series. So it looks like everybody's seated and anxious to listen to Tim, and so get this Prem Paul out of the way so we can get to business. But I've got to do a few things here before we bring our distinguished speaker here on the podium. Today's lecture is being web streamed live, so I also want to welcome those who are joining us via the web. For those of you who use social media, the Twitter hashtag for today's lecture is Neb Lecture. We're interested in learning about how you heard about today's Nebraska Lecture and invite our in-person audience to mark the choices listed on the cards on your seats. Our staff will collect the cards after the lecture. Hopefully, the guidance that you provide, we can use it for in the future. We've also begun a new partnership with Osher Lifelong Learning Institute, known as OLLI. We would like to especially welcome any OLLI members who are with us. Any OLLI members here? Yeah. Well, thank you very much for joining us. My special thanks to our host today, the University of Nebraska Athletic Department, for their hospitality. In the past year, we've teamed up with athletics to build a very powerful partnership between academics and athletics, between research and athletics. We're extremely excited about this truly unique partnership because there is no other place in the country, and I probably can say no place in the world that such partnership exists. And when I go and talk about this, people are just very envious and jealous. And they ask me for special tips and say, go away, we want to keep it unique. My special thanks to Sean Eichhorst and Tom Osborne for their leadership, and they really are great team members. I also want to recognize my colleague, friend, Randy York and Chris Anderson. They do a great job and really great partnership. Keep up the good work there. Randy, stand up there, please. This Nebraska Lectures are an interdisciplinary lecture series designed to foster communications among students, faculty in different academic areas, and our citizens of Lincoln and Nebraska. They are sponsored by the University of Nebraska-Lincoln Research Council in cooperation with the Office of the Chancellor and Office of Research and Economic Development. Research Council, for those of you who are not familiar with it, is composed of our faculty from multiple disciplines across UNL, and they are the ones who select these lecturers. And they're based on research, their accomplishments, recent accomplishments, overall accomplishments, and the ability of this lecturer to be able to communicate in a lay language to a broad audience. They also hold a lot of money, which comes through our office, and they give grants. And so the idea is seed grants, which results into bigger grants and interdisciplinary collaborations. A few words about today's format. After the lecture, Dr. Ken Bloom, Chair of the Research Council, will come up. He's also professor of physics and astronomy, and he'll moderate the question and answer session before we conclude. Usually, this is a three-way collaboration with Chancellor, but he had a scheduling conflict, and so rather than introducing Chancellor Perlman, I'll introduce myself. So it is a distinct honor for me to introduce our speaker today. With the spring game tomorrow, our venue and topic for today's lecture is very appropriate and very timely. Dr. Tim Gay is a professor of physics and astronomy. His research centers on polarized electronic and neutrino physics, pretty complex and high-powered work. His research has been funded by very competitively funded by organizations such as National Science Foundation, which is very, very tough to get, and very proud of him for his competitiveness. He's been the principal investigator on more than $6 million of grants. It's not just the grants, it's the competition is so intense. It speaks of the quality of the individual that we're going to be listening to. He has published more than 85 scientific articles. He is a fellow of the American Physical Society. Basically, that's a very high honor. They just don't let people in from the street or even from the department easily. He's chaired the Division of Atomic, Molecular, and Optical Physics. What it really means is that he's very accomplished. He's also a strong believer what he calls physics propaganda. He believes working scientists need to explain their work to the public. Very important for all of us. That's how Gay became a familiar face to Husker fans during the 1999-2000 seasons, when his football physics lessons were shown on Husker Vision during games. These one-minute videos featured UNL football players demonstrating basic physics concepts, such as how Newton's law of physics applied to blocking and tackling. He's also the author of Football Physics, The Science of the Game. My personal first exposure I came from some rinky-dinky universities in Minnesota and in Iowa State. And my God, I come here, I'm already blown away with the, Big Red and all the fans. And then, can you imagine with the 75,000 people here, and all of a sudden, the place went silent. Dead drop, pin drop silence. I said, what's going on? I look at the screen, and there's Dr. Gay. In today's lecture, Tim we'll learn from Tim a little bit about the history of American football, how the current climate could lead to changes in the game, and about research efforts underway both at UNL and nationally to better understand and mitigate injuries. Dr. Gay's interest in football started early in his life. As a prep school student in Massachusetts, he managed the varsity football team his senior year. Players on that team included Bill Belichick, who has coached the New England Patriots to 3 Super Bowl victories, and Ernie Adams, an assistant coach and research director with the New England Patriots. He earned a bachelor's science degree in physics from Caltech. While there, he played tackle for his football team, a squad so notoriously inept that it was profiled by the Wall Street Journal in the fall of 1974. A typical Caltech season record was 1-7. Against such football powerhouses as Laverne College or Harvey Mudd College. Thank goodness his record as a physicist and professor is a lot better, actually quite stellar. He earned his doctorate in experimental atomic physics from the University of Chicago. He was a research physicist and lecturer at Yale University until 1983, when he joined the faculty at the University of Missouri-Rolla, and then he graduated to the great university of the University of Nebraska Lincoln as a faculty in physics department in 1993. It is really my honor to introduce my great colleague, Dr. Tim Gay. Please join me in welcoming him.
Thank you, Prem. I want to thank you and the Research Council for inviting me to give this talk. It's really an honor. I want to thank all of you for coming and welcome you here to the West Stadium. What I think I should do to start out is to conduct a little class in Football 101. We know what Vince Lombardi said about football. It's really just blocking and tackling, and I happen to subscribe to that view. So let's see how to make a block. This is actually a block that Kenny Bell put on Devin Smith in the 2012 Big Ten Championship. And we'll run it a couple times so you can see what's happening. So Jamal Turner has the ball, and Kenny Bell comes in from the right and cleans out Devin Smith. Notice here, that hit. This is sufficiently beautiful that I want to show it to you one more time. We'll just play it once more. So there we go. Notice that Bell and Smith have about the same weight, but Smith is the one that goes flying through the air. I was watching this on television, and I thought, what an incredibly beautiful block that was. The prettiest thing I've ever seen. That's what football is all about. Let me just explain briefly the physics of what Kenny Bell did. This is a different picture. I couldn't get a video grab of the piece you just saw. This is actually a Navy Air Force game, but notice we have a running back who's on your right, whose foot is planted on the lower right corner, carrying the ball, and the Navy defender is tackling him. He's wrapping him up. Notice that's important. He's got his arms around him. It's important to wrap a guy up and not grab at him. Most importantly, though, the force that he exerts on the Air Force player, which is indicated by that red arrow, goes through the player's shoulder. Newton's third law tells us that the Air Force player will exert an equal force downward, but the difference is that the line of force exerted on the Navy player, the guy on the left, goes through his center of mass, so it's not going to really affect his stability, whereas the Air Force player has a rather large lever arm. That's the distance from his foot up to the point of contact, and is indicated with the L sub S. That makes him very unstable when he experiences that same force. So this is a picture-perfect hit. It's beautiful, just like the one Kenny Bell put on Devin Smith. And I watched this on television, and I thought, man, that's why I love football. And then he drew a 15-yard penalty for hitting a defenseless player. And I thought, what the heck is up with that? How can such a beautiful, picture-perfect block be penalized? And that's what I want to talk to you about today. There's a problem in football. I want to discuss that a little bit. I want to introduce some of the causes of the problem, which are rooted really in classical physics. Then we'll maybe hope to peer a bit into the future to see where our game of American football might go. So let's list what are the problems? And I'm listing these in no specific order and in no order of importance, but these are problems as viewed perhaps from disparate camps. Not everybody thinks the problem is the same, but this is just a laundry list. For example, for players, many players that have retired from the NFL, they're affected by chronic pain and loss of motor skills, much like Muhammad Ali. They shuffle when they walk. They've got constant headaches, constant burning joint pain. Bad stuff. A lot of these players suffer from depression. A lot of these players, we've seen 9 in the last year, commit suicide. That's a real problem. From a different perspective, there are big lawsuits being leveled at the NFL, some at the college level. We're going to talk a little bit about that. That's a problem for organized football, certainly. A problem that I see, both as an ex-player and as a physicist, is a disturbing trend in elimination of protective equipment. Players are getting bigger, faster, we'll talk about that, but they're losing their equipment. Many players don't wear thigh pads anymore. A lot of players on the line have stopped wearing horse collars. This is a problem. Concussions is really at the root of a lot of this. The problem for the game is concussions, but the problem with concussions is we don't really know what they are. And we don't know how they're caused, truly, in a scientific sense. So that's an issue. If we thought we knew what they were or how they're caused, maybe we could solve the problem, but we don't, and we haven't yet. A lot of people are disturbed by violence in football. That's sort of tied into what I think of as the inverse Hippocratic oath in football, which is first, do as much harm as possible. That's what my coaches taught me. One of my line coach was had played with the Lions organization for a number of years, and he was one brutal guy. And he told us to be brutal, too. In the academy, I think there's a problem with football as well. A lot of members of the academy feel that football is a vulgarization of the elite academic ethos. Certainly, Robert Maynard Hutchins, president at the University of Chicago, felt that way. In fact, he eliminated football from the University of Chicago's curriculum when they were at the top of the Big Ten. They had a winning record against every other team in the Big Ten, and he eliminated the program of football altogether. Since then, it's been restored, but they play Knox College, Wheaton College. So these are the problems. We can summarize them pretty succinctly. There are three threats to football. One is science. We've got a bunch of hand-wringing scientists who are focusing in on what's causing these concussions and what some of the real dangers of the game are. There's litigation. The NFL is being sued by one of the largest mass torts in the history of our legal system. And then there's the unfortunate problem of death. People have weighed in on this issue recently. Writers, players, everybody. Buzzy Bissinger, who I actually went to prep school with, said, that's because college football has no academic purpose, which is why it needs to be banned. A radical solution? Yes, but necessary in today's times. Do we really need to ban football from college? Interesting question. Malcolm Gladwell, who writes for The New Yorker and was named as one of Time's most influential people back in 2005, said, you see how hard reforming the game argument is going to be? Every time someone comes up with one thing that might reduce brain impact, it seems to raise another problem. My guess? Football slowly dies out. Look at the collateral damage this game has left in its wake. You have to ask the question, is it time to say enough? And finally, President Obama has said that if he had a son, he wouldn't let him play the game of football. That's a shocking, unique event in football's history. Before you think that it's a bunch of eggheads developing these opinions, let's hear what the players have to say. Bone Crusher Pollard says, 30 years from now, I don't think the NFL will be in existence. I could be wrong. It's just my opinion, but I think the direction things are going, where the NFL rule makers want to lighten up, they're throwing flags and everything else, it's going to come to a point where the fans will just get fed up with it. I was pretty darn fed up when I saw Kenny Bell get a flag for that block. None other than Terry Bradshaw, one of the greatest quarterbacks that ever lived, said, I believe soccer is going to elevate itself. I think baseball and basketball are going to become more popular, and the contact sports will slowly fade away. I wouldn't want my child out there. I'm worried about their head injuries. If I had a son, I wouldn't let him play football, echoing President Obama. There will be a time in the next decade where we will not see football as it is, I believe. Chris Collinsworth says, I have my doubts whether children should play football at all. Of course, if children aren't playing football, that's the end of the game. And finally, not a player, but a father of one of the great quarterbacks said, apparently, talking about parents who let their kids actually play football, said, they don't take their responsibilities very seriously, or they wouldn't, they don't value their children's health as much as they should. So why do we have these influential public figures trying to turn the United States of America into a bunch of soccer-playing communists? What's up with that? Let's talk about the NFL lawsuit. Here's another problem. This is a huge lawsuit. There have been about 4,000 players. They've now been brought together. They're trying to get their suits put together as one. This is approximately 1/3 of the retired living players in the NFL. And they're claiming that the NFL knowingly misled its players when they knew that, in fact, playing the game was dangerous, telling the players that it was safe. In 4 days from now, the court is going to decide whether these disparate suits can be put into one mass tort. My friend Professor Wilborn can distinguish between a mass tort and a class action suit. I'm not sure I understand the difference, but it's a big thing. The expectation is that, this is going to go on for a long, long time. So this is a real problem for the organized game of football. We've had, in recent history, two commissioners of the NFL that have taken decidedly different views of this. Paul Tagliabue, who just quit in 2006, had a very simple view of this. There's no connection between big hits and concussions. It's kind of like the cigarette people. And there is no link between concussions and CTE. CTE is a problem. It's called chronic traumatic encephalopathy, which is brain damage, basically, which we'll get into later. Research done by NFL-funded scientists and our helmet manufacturer has discovered that NFL players are impervious to concussions. This is good. They published these results in refereed journals, concluding that NFL players were supermen. He left in 2006. Commissioner Roger Goodell, who's in charge now, has a very different kind of view. He's very proactive about the situation. They're doing things aggressively. When they were confronted with the bounty scam down in New Orleans, he said, we're going to change the rules to solve this. We're going to aggressively pursue coaches that pay their players bonuses to hit extra hard. That's all my coaches ever told me, was to hit extra hard. We're going to aggressively show concern for our players. We're going to aggressively fund the NIH at $30 million, General Electric at $60 million, and Harvard University at $100 million to solve the problem of which we were previously unaware. And oh, by the way, there is no connection between this generous funding and the fact that our players are suing us. So that's an issue. There have been a lot of new rules recently to try to ameliorate this problem of concussions and injuries. Now the kickoff takes place from the 35-yard line. There's only a 5-yard run-up for the kicking team. The wedge is limited to 2 players on kickoff returns. Concussed players in the NFL, this is only an NFL rule, concussed players must be asymptomatic to return. That makes a lot of sense. But most importantly, the rule encourages them to be candid with their coach about whether they're ready to come back on the field. This strikes me as being naive, but independent, this is actually a good change. They must now, teams must consult independent neurologists in order to get a player back on. Usually in the past, they just consulted team neurologists. In the NCAA, we've now required that you can be penalized if you're not wearing a helmet on the field. That's good. Thigh pads and knee pads are now required in the NFL. Players were losing thigh pads and knee pads so they could be faster. They didn't like the limitation on the motion, and they've now put those back in. The NFL has now instituted what's called the crown rule. Basically, you can't lower your head and use it as a battering ram outside the tackle box. You can still do it inside the tackle box. And this is the relevant one for our discussion here today. A player guilty of targeting or blocking a defenseless player will now be ejected, as opposed to just penalized 15 yards, which is what Mr. Bell got. You can't do a peel back block now in the tackle box, which is new. Okay, so those are the new rules. Interestingly, it's sort of amusing to go through the NCAA rule for defenseless. What is a defenseless player, by the way? It's a player in the act of, this is what Kenny Bell was penalized for, a player in the act of or just after throwing a pass. That's not Devin Smith. A receiver whose focus is on catching. No, that's not him either. A kicker in the act of or just after kicking a ball. Devin Smith had kicked no ball. A kick returner whose focus is on catching or recovering a kick in the air. Nope. A player on the ground at the end of a play. Nope. Or a player obviously out of the play. Devin Smith was chasing Jamal Turner down at high speed, so I wouldn't say he was out of the play. What that means is that there's a real communication problem with the players. Do players currently on the field really know what a legal hit is? More importantly, perhaps, do the referees know what a legal hit is? Just speaking as a former player, it strikes me that many of these new rules are antithetical to good tackling or good blocking practice, and what my coaches always used to scream. They used to scream at me for some reason most of the time, not my teammates. You got to play every play at 110%. And you don't want to be calculating, okay, am I inside the tackle box? See, is my center of gravity too high? Is he defenseless? Let me think about that. No, you got to hit the guy. You got to hit him now, and you can't think about it. You just got to react. So this is a problem. Emmitt Smith, the NFL all-time leading rusher, said, if I'm a running back and I'm running into a linebacker, you're telling me, this is the crown rule, you're telling me I have to keep my head up so he can take my chin off. The players hate these new rules. So this is a problem as well. Fortunately, we've been saved by the U.S. government. Congressional hearings have now been convened by Tom Udall, or they were, and Jay Rockefeller back in 2011, and they have investigated Riddell's claim about concussions, which, as you'll see, is not that specific, and they did assess in these hearings the level of the problem. Perhaps not surprisingly, nothing happened. The National Institute of Health and the National Academy are now going to begin studies this spring into the problem as well. So maybe our problems are over. So what I want to do now is talk a little bit about what I think the real source of the problem is. Of course, it doesn't take a rocket scientist to figure this out. Football is a very violent game. That's what I love about it. How violent is it? Let's see. Here is a famous clip. It's actually the first one I ever used for football physics, and involves John Rood taking out the Oklahoma return player Kelly Phelps in a 1978 game. This is the first game against Oklahoma that Coach Osborne won. So here we go. Kickoff. Nebraska kicks off. Kelly Phelps gets the ball and returns. And here comes Rood. And we've got this it gets better. We've got this in slow motion. Here we go. So he's got the ball. He's coming up. And here comes Rood. Beautiful hit. Just classic textbook hit. Really just like I showed you with the Air Force and the Navy. So let's analyze that from a physics perspective. I want to emphasize to you that what you see on the football field is basically classical physics in action. Classical physics was invented by Sir Isaac Newton and essentially was all of physics until 1895. I don't want to say all, but it was much of what we understood about mechanics until 1895 when modern physics took over. But essentially when you see a football game, you're watching classical physics. Here we have two players in a classic tackling blocking pose where the player on the right, who is player number 2, exerts a force F21 on the player that he's blocking. Newton's third law again tells us that they will exert equal but oppositely directed forces on each other, which is fine in this picture because both players look about the same. Where it gets a little surprising is when a player like Lawrence Taylor, some big defensive end, cleans out Doug Flutie, who weighs, 170, dripping wet. When a huge player cleans out a small player, one of them running fast, the small player standing still in the pocket, the forces they exert on each other are still equal. So that's a kind of a surprising result. The reason Flutie is the guy that goes flying is because he has smaller mass and is more easily accelerated, which brings us to Newton's second law, which is the important one. And it says that the force that the lower player exerts on the upper player here, the player on the right exerts on the player on the left, is equal to the mass of the player on the left, m1, times his acceleration. Now the other definition, I promise you, this is I think the only technical slide we have. The acceleration is just the time rate of change. It's the change of player 1's speed over the time it takes that change to occur. Now typically in these collisions, the whole duration is about 150 milliseconds, 0.15 seconds, and in big hits, the player will be running at nominally 10 meters per second and come to a stop. If you have a nice symmetric collision where both players collide and fall to the ground, you've got a change in speed of 10 meters per second, and that occurs over 150 milliseconds. That's what's indicated on the third line here. We divide 10 meters per second, the delta V, the change in the speed, by the change in the time, which is 0.15 seconds. That gives us the acceleration. We multiply then by Phelps's mass, which is nominally 100 kilograms or 220 pounds, and do the math, and you get 7,000 newtons, which is about 3/4 of a ton. There's a technical physics term for this. It's called getting your bell rung, and these are big forces. So this is not surprising then that there might be some injury as a result of these kinds of forces. Here's another example. This actually occurred in the AFC Championship this year, where there was a little collision between Ray Lewis and Aaron Hernandez of the Ravens. So let me try to find it. Go. Let's watch this. This is all in slow motion, and let's see what happens. Well, nope. We'll get this organized. There we go. Again in slow motion. Ray Lewis is number 52, and Hernandez has the ball and is coming up. Drops his head. Ray Lewis is trying to get out of the way. Heads collide, and Hernandez falls down. Just perhaps not surprising. We've got, I think, another version at a somewhat greater speed. Now we're running it backward. We'll watch it one more time forward. This is a violation of the crown rule, where you're not allowed, even in the tackle box, to use your head as a spear, to lower your head and use it as a battering ram, essentially. So let's watch this again. Here we go. Another angle. Oops, here we go. Same angle. So watch the heads. Lewis is he's trying to get out of the way. He's lowering his shoulder as he should. And Hernandez says, nope, I'm going after you, buddy. Now, what kind of forces do we have in that situation? Well, we do the same kind of calculation, except now, because the head is decoupled from the rest of the body by the neck and spine, we'll use the lower mass of the head. So initially, you can estimate that the speed of Hernandez's helmet is about 5 meters per second, and it bounces back, moving the other direction at 5 meters per second. Again, for a delta V, delta, the capital Greek letter delta, indicating change, the change in V being about 10 meters per second. But there's a big difference now. In helmet-to-helmet collisions, the time of interaction is much shorter. Because those are two hard surfaces, they take place over perhaps 20 milliseconds or 2/100ths of a second instead of 150 milliseconds. So it's a much sharper collision. Typical human head has a mass with helmet of about 8 kilograms. When you do that math, you end up with something like 900 pounds. But that's the average force. That's the force he'll feel over that 20 milliseconds. That can peak up to something like 2,000 pounds at the height of the force versus time graph at the peak of the collision. That's about 100 Gs. It's basically like getting a 16-pound bowling ball dropped on your head from 8 feet. Again, another issue. How do head injuries work? Here's another example of head injury. Basically, they occur in two ways. If you're hit head on, you have what's called a linear acceleration. And essentially what happens is that the helmet is pushed back against your skull, and your brain, which is not completely tied down within the cranial cavity, rattles back and forth. What we're beginning to understand is that there's a worse kind of collision. There's a collision that's worse, and that is a rotational hit where you actually get the head spinning around the neck, if you will, and the brain is rotating quasi-freely within the skull, and that appears to cause bigger changes in terms of the lining of the brain with regard to the skull itself. Football helmets are pretty good at minimizing the effect of linear collisions, but they don't really have any effect on a rotational collision, as we see in this next picture. This is actually an analysis done by the National Geographic on all of the hits that a lineman, playing at UNC actually, sustained in one season. And you see all these little lines. The length of the line is essentially a measure of the force that the player felt, and the locations are, of course, indicated where the lines intersect the helmet's surface. So you see most of them, as you might expect, are up front. Interestingly, this player sustained 2 concussions during this season of play. Those are indicated by the black lines. You can see it on the right-hand picture. The lower long black line, which is about 120 Gs, caused a concussion. Notice also, though, that there's a shorter black line heading directly in to the player's forehead. It's a rather weak collision, but it also caused a concussion, and it's actually a direct linear acceleration. The bottom black line would cause a rotational acceleration about an axis parallel to the ground, and that's what really produces the worst kinds of concussions, although apparently they can happen in any sort of scenario, as evidenced by this graphic. There's yet another problem. I analyzed this in my book. This is kind of obvious, but it's interesting to see the numbers. Players are getting heavier. From 1920 until today, player mass on the line in the NFL has increased from about 190 pounds to about 300 pounds. So roughly a 57% increase over that 85-year period of time. So players are more massive. There's a concomitant increase in other position weights as well, but the best data is for linemen. Players are getting faster. Unfortunately, there are very few 40 times listed for linemen in the Canton data books. What I did there was to say, well, we can estimate how fast players are getting by measuring record times in the 100-yard dash. So what you see here, the blue data points, are essentially speed inferred from a standard running model from times in the 100-yard dash. You can see them increasing. Notice, interestingly, they're sort of not flat, but they're not increasing as rapidly as usual from about 1965 to about 2000. And then, of course, the Jamaicans come in, and Usain Bolt takes that through the roof. That's his world record at that last data point. But basically what I said is, all right, linemen are not as fast as world-class sprinters, obviously. They're roughly 85% as fast. So we'll put in that number. Still, you see that there's about a 10% increase in that same 85-year period in lineman speed. Now, if you take speed and you combine it with mass, you get energy. And energy is what causes injuries. And when I do that, you have to square the speed, multiply by the mass. You get a number that's essentially doubled. It's an 85% increase in that 85 years. So the amount of energy that goes into potentially injury-causing collisions in the pit has doubled since the inception of pro football. So that's an interesting problem. It's especially interesting when you consider players are losing pads because they don't like the limitations that the pads place on their mobility, their ability to react to things. So again, given these 3 examples, it's kind of obvious why we've got concussion problems and injury problems. There's another problem here. Let's consider law schools. What I've got here is a graph of the number of law school graduates since 2006 to 2011, and it's basically flat. It's coming up a little bit. I've also plotted in the middle set of data the number of jobs requiring bar admission, which is going down, and simply the difference between those 2 curves is the number of unemployed lawyers. That's plotted in the green data at the bottom, and in the last 5 years, well, since 2006 to 2011, there has been a 56% increase in the number of unemployed lawyers. These are smart people. They're going to figure out what to do with their time, And I suggest to you that one of the things they may be doing with their time is finding people to sue, as you can see from the ubiquitous legal websites. If you Google big hits in football, chances are 9 out of 10 that you're going to get a legal website. And you can press a button and get legal help now. What are the medical issues? Well, there's chronic traumatic encephalopathy. Players are committing suicide at a record level, and in the 34 brains of NFL players that Boston University analyzed, 33 of them had this problem. It's basically a chemical indicating damage in the brain, and that chemical was present in 33 out of 34 examples that they checked. NFL players are 4 times more likely to die of Alzheimer's disease or Lou Gehrig's disease than the general populace. Youth football is huge in this country, but the skeletal system of a young kid and the brain are developing, and if a kid gets whacked, the potential for brain injury is much, much greater. And you say, well, wait a minute, yeah, but these are 80-pound kids. How big a hit can they deliver? And the answer is pretty big. They have put accelerometers in the helmets of Pop Warner players, and they get up to something like 80 or 90 Gs, which is sort of typical of a college game. Those are exceptions, but it does happen. And so there's a real concern here that our youth are at risk. There are other problems. I emphasized earlier, I want to emphasize again, that we don't really know what a concussion is. I've talked to real experts in this area, Dennis Mulfees being huge in this area, and that's what his research is about. They're trying to figure out, I'll tell you more about East Stadium later, but one of the goals is to figure out what the heck actually is a concussion and what causes it. Big hits don't necessarily lead to lesions. They don't lead to bleeding. So it's hard to pick those up. What we do know is that the cells of damaged brains and the chemicals in damaged brains are easily recognizable, and there are hopes that we can use those kinds of issues, the morphology of nerve cells and anomalous chemical compounds in the brain as a marker for whether a player has suffered a concussion. The problem is some players seem to get CTE, some don't. So the epidemiology of this problem is again also not well understood. People have argued, the NFL being at the head of the pack, that these results from Boston University are skewed because you've only taken people that have committed suicide. They were so depressed, well, sure, they've got brain damage, they killed themselves. So of course you're going to see that there was brain damage. Maybe, maybe not. What causes a suicidal depression? Is it the chronic pain, the fact that you go to sleep hurting? You wake up hurting, or is it that your brain is really messed up? One thing that's become clear, though, in the last 10 years is that many small blows are almost certainly as bad as a couple of big blows. So the blows that a lineman experiences, where they're not up to full speed, are going to probably be just as bad as situations where you have a big hit between a safety and a wideout. We do a good job here at Nebraska of concussion assessment. I've talked to our doctors, and they're very concerned about this issue, and they're really on top of things. On the field, on the sidelines, we have a number of ways of checking to see if a player is concussed. We check their balance. Do they have a headache? What's their reaction time? Something Dr. Albers told me about, a SCAT card, basically has a list of questions that you can ask the player quickly. Ultimately, if the player seems kind of okay, but the doctor still has suspicions, he'll take him over to Coach Pelini, and Coach Pelini will say, okay, you've got Red Dog 39 with an off-tackle play to the left. What do you do? And if the player has to think about it, of course they're trained to react like that, then there's probably a problem. Ultimately, though, the decision on whether a player is concussed is made not by the coach, but by the team physician. Off the field, if you suspect that a concussion has occurred, we've got CT scan capability, we've got MRIs if lesions are suspected. There is an extensive battery of psychological tests that the players go through. First is a baseline when they start in the program, and indeed every year. And then if you suspect that they've suffered a concussion, you can make them take the test again, and you've got a lot of detailed markers to compare. So people are worrying a lot about assessment, and I think it's as good as the state of psychology and neuropsychology allows at this point. So let's talk about the solutions. What's the hope for the future? There are a number of solutions, and I'd like to go through them one by one. There's this one, which seems to be right now what the NFL is thinking in terms of its rule changes. For those of you that can't read it in the back, now promise me you will all be very careful, which is, yeah. But there are better solutions. Let's talk about rules for a moment. I think, and this has been discussed a lot in NFL meetings and NCAA meetings, obviously you have to rule out things like bounty programs. The NFL has come down like a ton of bricks on the New Orleans bounty scandal. The idea of having no kickoffs at all has been discussed. You could have bigger halos for punt returners. You could have stiffer penalties. You could do a serious job of testing for drugs, which I don't believe the NFL does, for human growth hormone, et cetera. The NFL has now jumped on the bandwagon of requiring more pads, so that's good. And again, I think you could codify in the rules a much higher bar for a player to return to the game after he has suffered a concussion. So I think stiffer new rules would be a good idea. I don't necessarily agree with this list. I'm just reporting to you the ideas that have been discussed. That's an interesting issue. Let's talk a little bit about history in terms of rules. In 1903, President Eliot of Harvard said, referring to the rules of football, they're justifiable in that consummate savagery called war, but they should have no place in sport. No sport, he's a congregational minister, no sport is wholesome in which ungenerous or mean acts which easily escape detection contribute to victory. Eliot, at the university where football was at least partially invented, wants to get rid of the game. The New York Times, 5 years later, ran the following bit, comparing football to lynching. A young gentleman engaged in getting an education ought not to exhibit himself for money. And he's talking about playing football, and he and his fellows ought not to raise a mere sport to the dignity of an occupation. He's talking about the NFL, which didn't exist at the time, but that's the idea. The tremendous loss of time which over-attention to football occasions is its worst feature, though the brutality and maiming are serious evils too. Both will be cured by cutting off the money supply, which the faculties can do by a two-line resolution. Make lynching expensive and public football unprofitable. So, historically speaking, we've been there before. What happened? Well, what happened is that Teddy Roosevelt came to the rescue of our game. He had been quoted in 1893 as saying, "The sports especially dear to a vigorous and manly nation," that's us, are always those in which there is a certain slight element of risk. It is mere unmanly folly to try to do away with the sport because the risk exists. He then, as President of the United States, something our current president doesn't seem to be willing to do, called a meeting at the White House of the athletic directors and coaches from Harvard, Yale, and Princeton, as well as the Secretary of State. And from that, the NCAA was born, really leading, frankly, to modern football. The first thing the NCAA did was to institute the line of scrimmage. The forward pass was put into the rules. They required the use of helmets and pads. They eliminated the scrum, which was sort of a vestigial result of the game evolving from rugby. Multi-man wedges. They instituted the penalty system and the 10-yard first down. So those are things we've come to know and love now. Solution number 3. Let's talk, this is Jack Lambert, smiling at the camera. Clearly another solution is better equipment, better helmets, the return of the horse collar illustrated here, and I think a requirement in the rules that we not wear pads. I think pads are important. Okay? People used to wear horse collars back in the 70s. I wore a horse collar. What's the advantage of a horse collar? It keeps your brain from rattling around relative to the shoulders. We know that a major source of concussions is a transverse hit to the head causing a rotation. Horse collars do a good job of preventing that. Nobody wears them anymore. Why? Because you can't move around and react as quickly. That's a problem. Let's talk briefly about helmets. The University of Nebraska is partnering now with a company in California to make better helmets. We're excited about that. How does a helmet basically work? First of all, the helmet's shell distributes force. The thing that's crucial in a hit is not the force per se, but the pressure. You want to lower the pressure. Nails work, of course, by an inverse pressure principle. They concentrate the force into a high pressure. What we want to do with the polycarbonate shell of a football helmet is to distribute the force so it lowers the pressure. The other important thing about a helmet is the padding. The padding lengthens the time of the collision. In the same way, if I took 2 eggs and dropped them from a given height, one onto linoleum, one onto 6 inches of foam rubber padding, the linoleum will break the egg, the foam rubber padding won't. The change in the momentum of the egg is the same. They both come to a halt, but the collision between the egg and the floor is lengthened by the padding, lowering the force. You can see this in the 2 graphs. I've plotted the force of a collision versus time. If I just have 2 skulls bashing together, you see the graph on the left. The area under the graph, that purple area, must be the same in both cases. That's the momentum transfer to the helmet, to the head. That has to be the same, but if you use foam to lengthen the collision, that baseline in the right-hand graph is longer. To keep the area the same, the maximum force has to decrease, and that's what padding essentially does for you. Having said that, I think we're about as good as we're going to get with helmets. People have been worrying about foam for a long time, and the idea behind how a foam prevents concussions is understood. The science is clear, and we're not going to do a much better job of producing better foams to absorb all that energy. Helmets might get 10% better, but they're not going to get 300% better using the simple shell foam model. So I'm not optimistic yet about big changes that are at least based on the foam shell model. Recently, though, as a result of all the NFL problems with lawsuits, there have been a lot of proposals for new helmets. Here's an example of one. This actually came out about 1995. This is the Pro Cap Eliminator, and it's very impressive. You see, you've got the normal football helmet there, and then there's a foam cap on top, which is basically just more foam. And you can see that it's been adopted by Tulane and Kansas and the Army and all these, and I think that's the M51 Galaxy in the background there. I'm not sure. It's very impressive ad, and a number of pro teams, especially the 49ers, started wearing these things. Here's an example of that. The problem is that when you have a big foam cap on top of your head, it does in fact reduce the force that you'd feel otherwise. The problem is, well, there's a reason why they take those football helmets and shine them up to a beautiful shiny glow. It's not to make them look good, it's so that when 2 helmets collide, they bounce off each other. There's no transverse friction going on. And if you put a big, especially one that's dug up like this, a big foam cap, the opposing player could just grab it and rip your neck around. Indeed, that's why you no longer see these, because neck injuries were going through the roof with these things. And they're equivalently stupid ideas that are popular now. Here's one. Let's take a bunch of strips and glue them to the top of the helmet. This is called the shock strip. And you can see on the left there, the little kid with the G helmet has got these shock strips on his helmet, which gives the opposing player something to grab hold of and rip their neck around. So this doesn't strike me as being a good idea. They were trying to get Jay Terry to buy these things, and we didn't think that was such a great idea. Notice, and this is typical of helmet manufacturers, they sell these great products, and then, on the advice of their attorneys, they put in statements like, contact in football may result in concussion brain injury, which no helmet or exterior device can prevent. Therefore, shock strip assumes no responsibility for any injury suffered while using our products, which we just sold you because we told you they were going to eliminate concussions. Okay, there's another thing I want to hit on briefly, which is the STAR system, developed at Virginia Tech, which is, I believe, a flawed but temporarily useful method for assessing football helmets. They've taken the medical research that has been done in terms of hits, they've put it into a mathematical formula, and they do extensive testing of all the helmets on the market. Professor Namas Chandra and I have been looking into this, and he can tell you better than I can what the problems with this system are, but basically it's the best we have right now. We are hoping that we'll improve the system, but right now we have the STAR system. And notice then that the Riddell 360 is at the top. The Zenith X1, which Ray Rice has been touting as being the helmet of the future, does not so well. And you go back to the old VHS4, which everybody wore 10 years ago, and that's at the very bottom. So things are, if I had a son playing football right now, I would say you go out and you get that Riddell 360. Not because it's for sure the best helmet, but the data that we have, even though it's minimally valid scientifically, tells us that that's the helmet to wear at this time. Another brief point, and that is that there exists now a system developed at North Carolina State where you can put accelerometers, force transducers, into helmets and measure to see if your player got a big hit. That's actually what produced that sort of spiky diagram I showed you with all the hits. So you can have a computer on the sidelines and you can tell when a player has been hit by a big force. Stanford, interestingly, has pioneered an accelerometer in the mouthpiece method, which is interesting and gives equivalent data. The most important sociological point here is that the NFL players hate this idea. They don't want science injected. Hines Ward, who used to play for the Steelers, said, you start adding science to the game. I mean, some doctor with a computer starts taking plays and money away from players. The players won't even look at the hits system twice. There have been 7 colleges now that have adopted this. I don't see why more colleges don't use it. It doesn't affect the game, the way the game is played at all. It just gives you information. The NFL keeps swearing that they're going to look into this. They've been swearing that since 2007, 2004, when the system was introduced, and they've done nothing about it. Finally, let's talk about a fourth solution, sports science at the frontier, the East Stadium Research Complex, which has been developed here. Prem was talking about it earlier. I think we've had some really visionary efforts in this area recently. It's certainly true that Harvard, Yale, and McGill invented football, but it's really been Nebraska that's had a long-term history of improving the technology, back to Boyd Epley's days with strength training, conditioning, nutrition. Tom Osborne was involved with first use of field turf in a college stadium. These are major developments in the game's technology, and we're right at the forefront at Nebraska. What's going to happen now is that in the East Stadium, shown here, there are going to be 2 major labs, one for athletic performance, which will be run by Dr. Judy Burnfield, and then the Center for Brain Biology and Behavior, which Dr. Dennis Mulfees is in charge of. These are really cutting-edge developments. The fact that we're willing to put this in our athletic facility says volumes about the desire to partner between athletics and academics here at the university, and is just a visionary plan. The CB Cube, the Center for Brain Biology and Behavior, will have MRIs. I won't go through the whole list. It's going to have incredible facilities over there in East Stadium across the way that will give us state-of-the-art research about this problem. So that's incredibly exciting to me. The Athletic Performance Lab, again led by Dr. Burnfield, has really state-of-the-art equipment for assessing an athlete's performance. Professor Chandra and I are working on helmet research in that effort. There's just going to be a huge amount of state-of-the-art athletic performance technology going on as well, all in the same place, all within the athletic department, but run by academics. So this is very, very exciting to us. So finally, we're about done. Let me just talk briefly about some possible ways forward here. These are my proposals. This is my opinion. I've been studying this problem for a long time. Here's what I think we should do. I think we should make mouth guards mandatory. They are shown to reduce concussions. We all wore them in college. Now a lot of college players don't wear them, and the NFL doesn't wear them either. I think that's sort of an obvious thing. It might be a good idea to require players in the NFL to sign a waiver. You won't sue us. If you want to play, how bad do you want to play? Well, if you play, you're not going to sue us. That's an idea. I'd have to talk to my attorney friends to find out what they think of that. I think that the NFL should be aggressively testing, the operative word being aggressively testing for performance-enhancing drugs. We want this to be a human game. I think we need to redouble our efforts in careful baseline neurological monitoring. And I think, again, our effort over in the East Stadium is going to lead the way on that. Going to a 14-game schedule would not be a bad idea. Have just 2 preseason, a concussion that you suffer in the preseason is just as bad as one that you suffer during the regular season. Maybe get rid of the greatest hits videos. I'm guilty of this. I go out and get the latest greatest hits video. I love those things, but it glorifies the violence. I'm not sure that's the message we want to be sending. I'm ambivalent about that idea, but it's a thought. Again, more pads, more pads, more pads. A better understanding of the causes of chronic traumatic encephalopathy, and maybe we need to go to a licensing board, just like boxing. Players would be licensed to play. That might improve things as well. Those are my suggestions. Where do I see the future in this game? I predicted, as predicted by Malcolm Gladwell, that football would go the way of boxing. I predicted it won't. Boxing is a European violent sport. Football is an American violent sport. It's our game, and we love it, and we're not going to let it go. I think there will be coaching changes. When I was playing, concussion was a badge of honor. If you were playing hurt, that was a good thing. The players would tell us, point out, if you think the guy next to you is addled, point out which guy he's got to hit on the next play. There's a whole macho culture there, which has good points and has bad points, but I think maybe we need to worry about how it affects a player in the future after they retire. I predict that there won't be any implementation of the HIT system because the players in the NFL won't allow it. I think the litigation mania will diminish. The good news is that law school admissions are dropping like a rock. The trend toward less equipment will reverse, and I think we will start seeing more pads and horse collars. Equipment will get 10% better. I think there'll be some evolution of the rules. I hope that will stop short of no kickoffs. I think kickoffs are an important part of the game. Again, just my opinion. I think players will sign waivers after a while, and I think enhanced medical understanding, such as we'll be getting from East Stadium, will teach us what works and what doesn't in terms of equipment developing, which will be happening right next door. So that's very exciting. And finally, I think, slower return of players to the game is something that's going to inevitably happen. So that's what I see for the future. I'd like to thank you for your attention. I do want to take a little bit of time to acknowledge people that have really helped me with this talk. First of all, the Research Council for inviting me and running this program, which I think is great. Our team physician, Dr. Lonnie Albers, and I've learned a lot from him. Dr. Cliff Bettis in my department has taught me a lot about Newton's third law, if nothing else. And then Drs. Burnfield and Mulfees, who will be directing the effort over there, have also sent me a lot of information for this talk. Dr. Chandra, who is developing helmets that I'm looking forward to working with, and we've talked a lot about helmet technology already, along with Doak Ostergaard, who's part of this development effort as well, and who's a great colleague. My wife, Kirk Hartman, who sent me a lot of the videos I showed you today. Dr. William Moss, who's done a lot of work on simulations of helmet collisions, has helped me a lot. Jay Terry is our team equipment manager. I've learned a lot of stuff from him. And Karen Underwood and Steve Wilborn has helped me a lot with the legal issues. I'd like to mention specifically, though, in this list, Jeff Schmall, who was the head of Husker Vision for many years before he moved to Texas A&M. Jeff was the one that came up with the idea of the football physics videos that I did for 5 years, and I learned so much from him about communicating science to the public. He was just a real visionary in that area, and I always try to thank him in these kinds of situations because I owe so much to him. And finally, and most importantly, I want to dedicate this talk to Dr. Fuller, who died last year. He was the one that nominated me to give this talk and was so involved with communication of science, both in the classroom, in which he developed a lot of new techniques, and also in terms of giving talks to audiences such as this. He was a real mentor and friend to me, and I miss him a lot, and I want to dedicate this to him. And with that, I thank you for your attention, and if you want, you can buy my book over in the corner. Thank you.
Good afternoon. I'm Ken Bloom. I'm the chair of the University Research Council. We're the sponsors of the Nebraska Lecture Series. We're glad you could join us today. We've just actually recently made our recommendations for next year's Nebraska lecturers. I'm not allowed to tell you who they are, but they're going to be really great, so please look for notices of this series for next academic year. But for now, it's such a pleasure to have with us my departmental colleague, neighbor, and friend Tim Gay, who just gave us a great talk. We'll take your questions now. If you're going to have we'll have microphones circulating, so the people on the webcast, listening to the webcast, can hear you. Please be sure to buy a microphone. So we'll start over here.
Well, I will start with two comments, and one is just to thank you for what really good description of the problem and also of the physics. But also, Prem and Paul greatly overestimated Caltech's football as far as a record. I don't know where you got 1-7, but have there been studies comparing football with helmets with Australian rules football and rugby in terms of head injuries? And is there any potential of evolving to a football without helmets as an even safer method?
Yeah, the answer to your first question is not that I'm aware of. I'm not sure of anybody that's compared injury rates either with rugby or with Aussie rules. There's certainly an injury problem in both of those. I cannot cite a specific source, but my impression is that the injury rates in rugby are about the same as they are in football. I seem to have read that somewhere. I don't remember the specific source. But of course, many people have suggested that a way around this problem is to eliminate helmets altogether, which is a bit counterintuitive until you realize that, well, maybe they won't use their helmet. It sort of would help enforce the crown rule. There would be now the crown of your head instead of the crown of your helmet. But if the best estimates of injuries back in the early days of pro football, when they didn't use helmets, when the Decatur Staleys played the Canton Bulldogs, was that the injury rate was much higher than it is now. So I'm pretty sure that getting rid of helmets is not a good idea.
Professor Enders.
So after having paid attention very carefully to your wonderful talk, I have the impression that you have overlooked the most obvious rule change to propose, which is to limit the weight of the players to 160 pounds.
Microphone.
As long as that's for Pee Wee football, yeah, I think that'd be a great idea.
Other questions?
Professor Enders is one of those soccer-playing communists I mentioned.
Over here. And Karen. Back up for you.
What are your thoughts about eliminating the three-point stance?
I'm sorry.
Eliminating the three-point stance?
Eliminate the 3-point stance.
Yeah, that's been floated.
Yeah, let me repeat
The question is, what are my thoughts about eliminating the three-point stance, which has also been floated? I think it would dramatically. I think it's a bad idea because it would dramatically lower the energy of collisions, which is one of the things that's a crucial strategic underpinning of the game of football as we know it. Using force and mass to direct the flow of the people and the ball is crucial, and if you've got to just stand up and go somewhere, you become less of an exciting dynamic game. I want to emphasize, I'm basically in favor of the status quo, if that didn't come across, with some alterations, which I think are inevitable.
Anything?
I'll jump back to the soccer playing communists. When my granddaughter was playing soccer, she was tall and they always wanted her to do the headshots, and I'm going, no, please, no. Talk about headshots in soccer.
Yes, that's a very that's a very good point, and I should have made that. In fact, concussions are endemic to soccer as well. There's real concern about that, and it's not most of the problems I discussed are exacerbated by the game of football, but they exist in all sports. And soccer is one of the ones that doesn't get talked about a lot, but those headshots are just bad. Again, it wouldn't have to be a huge hit. It could just be a small hit, such as all the players have experienced over and over for an extended career. And I'm unaware of any studies that have been made, though, of soccer players in terms of CTE. And that's a very good point. I'm glad you made it.
Okay, my question's in regards to the waivers. Do you think that if they do implement it in the NFL, they might as well start with high school signing waivers, saying, I understand I'm going to be injured, basically?
Good question. I think, yeah, that plays on our sentimental view of the world, doesn't it? Should youth play potentially violent games? Indeed, we can take it a notch down and deal with Pop Warner League. I think the answer is yes. I think I would be. I'm shooting from the hip. The answer would be yes. They should sign waivers and either play or not play. Yeah,
I mean,
in high school.
It's a Steve Wilborn question, but is a high school student competent to sign that waiver?
Maybe in consultation with his parents.
Over here.
Dr. Gay, if your teaching methods of, like in this class here, could be multiplied over science teachers through elementary and high school grades, we would have the greatest boom in the interest of science, and we would be the leading producer of scientists. Thank you. Thank you.
I very much appreciate that kind comment, but I want to emphasize that we have great science teachers that are doing a wonderful job. I mean, I think they're all interested in that effort to communicate science in an interesting way.
Actually, I keep telling him that in the hope that he'll start covering my classes for me. But, anything else? Okay, we'll turn it back to Prem to make some closing remarks.
Wow, what a lecture. Woo! Wasn't that great? But then I knew it would be great. You know, Tim does a really great job, not only the lectures, but he's a great teacher and as well as a great researcher. So very much appreciate, Tim, you taking time and sharing your wisdom with the rest of us. Just want to remind you that the physics of football books are being sold by University Bookstore, and Tim is going to be available for autographs, and I'm going to buy one, Tim. There's a really one of the benefits of this lecture is that we give you a one present, and it's not money. Tim, it's a picture of the poster we prepare, and we're going to put a copy of that in the research office. And this copy is for you to display in your office. All right. So again, thank you very, very much for your great presentation.
Thank you.
Well, thank you all for taking time and coming and interacting with us and listening to Tim, and I hope to see you at future Nebraska Lecture and other seminars. Have a great day. Thank you.